Okay, so we're looking at the example number 1. It's called the square root function. And we want to graph the function we have in front of us given a certain number of transformations. So to save time, what I've done is actually listed all the transformations right here. Feel free to copy them into your own, or just print out this and you have them all listed there for you. Okay, the ones to probably make most note of is we have here a reflection in the x-axis, so that's the negative in front of the 3. As well, the reflection in the y-axis, that's this negative in front of here. Okay, so our square root function is going to be reflected twice. And we want to see what kind of effect that has on our graph. So let's start with the process here. So step number 1 says we begin by just listing our basic values for the root function. So we're taking, in this case, the function f of x. F of x equals the square root of x. And just kind of cycling through the numbers 1, 0, 4, and 9, taking their square roots to give us what we see at the side. For step number 2, move over here. Here's where we have some new information. Okay, new stuff from this lesson. So the y values are multiplied by a, which in this case is -3. So for y, I'm going to put times -3. And for the x values, we multiply it by the reciprocal of b. So if b in this case is -1/2, the reciprocal of b will be -2. Let's write out our x and y values. 0, -2, -8, and -18. For the y, I have 0, -3, -6, and -9. There is your step number 2. Third step, which we've looked at before, is just adding the h's to the x's and the k to the y's. So in this case, my x values, what do I have? -10, so that means I add 10. So it'll be plus 10 here. And for the y's, just looking at the equation, taking a peek, I add 2. So this is everything from the previous table of values. So 0, when I add 10, I get 10. -2 and 10 is 8. 2, and -8. For the y values, I get 2, -1, -4, and -7. And those are the points we are going to graph. Those final coordinates is what we put on our grid. So let's move over to our grid right now. So first point, 10 and 2. So 10 and 2 is going to be way out here. And then I have 8 and -1. It's going to be over here. 2 and -4. It's going to be over here. -8 and -7. So -8 is out here. -7 brings us all the way down here. Those are my points. Carefully, I connect them with a smooth line. That's the best I can do for now. Hopefully you have a steadier hand than me. And there we go. So there is our square root function. Let us now look at our domain. In this case, the domain is going to be everything less than or equal to 10. So x is less than or equal to 10. And that's because, again, if you look at your graph, 10 is out here. Everything to the left of 10 is legitimate for our function, because every time we plug in an x value, we get a corresponding y value somewhere down there. As far as our range goes, well, the topmost point is 2. That's up here. Oops. 2 is up here. So my range is going to be y is a real number such that y is less than or equal to 2. And there you have our square root function graphed for you. We want to take a look at now at our half circle function. The function in question is given over here. It's not exactly in legible format the way the method we've learned to graph. Okay, so you'll notice that we need to kind of identify the b value, identify the r value, which is the radius, and our h value, which is not so clear from the way we have it. So the second part says in our function, we ask if our function is in the right form, and the answer is no, because we need to have the x by itself. So let me just copy down the original function, f of x equals negative, and that's negative 1, over, now instead of 16 I'll write 4 squared. That makes explicit what our radius is, and in front of the x we have a negative 2, which I'm going to factor out from the two terms inside the brackets to give me x minus 1. And that's all squared. Just maybe redo this top line. And finally I have the plus, sorry, not plus, but in this case minus 3. And that is not included underneath the square root. But in this case, we can easily distinguish our values, okay? Our a value is over here, which is negative 1. R, the radius, is 4. Our b value is negative 2. Our h value is 1, and our k value is negative 3. So with this in place, let's start graphing. So we know that our basic function for the half circle, well, it's going to go from negative 4 to 0, negative 4 comma 0 to 0 comma 4 to 4 comma 0. Step number 2, we multiply all the a values by y and all the x values by the reciprocal. So y will be times negative 1, and the x values will be multiplied by, well, the reciprocal of negative 2 is negative 1 over 2. So what do I get here? Well, negative 4 times negative a half gives me 2. 0 remains the same. 0 remains the same on the next line. The y value becomes negative 4. And my x value here becomes negative 2. Moving on, final step is I'm going to add 1 to the x values, and I'm going to subtract 3 from the y values. What does this give me? I get 3, negative 3, 1, and we have here negative 4, sorry, negative 7, and then we have negative 1 and negative 3. So what do our points look like? On my graph, I go 1, negative 3, that means I'm over here. Sorry, that's not right. I'm looking at 3, negative 3. So 3 across, 3 down, brings me here. 1 and negative 7 brings me here. And negative 1, negative 3 brings me here. If I connect my dots, this is not a parabola. It's more like a half oval. I don't put lines on the end, I just leave it as it is. But there it is, my transformed half circle. In terms of the domain, well, before I write it out, let's just notice that domain is everything from here to here. So from negative 1 all the way to 3. As far as my range goes, it's everything from negative 7 all the way up to negative 3. Let me write that down now. So domain x is a real number such that x is in between -1 and 3, and for my range, y is a real number such that y is greater than or equal to -7 and less than or equal to -3. Here you have our half circles graphed for you. And next we move on to the absolute value function.